right, here we go. Chapter 2-8, two-variable inequalities. Now, first of all, to have an inequality, you must have less than or equal to, greater than or equal to, less than or greater than symbols. Those are your 4 symbols that you can have. Everybody with me? Yes? Okay. Now, a boundary line. If you say stay in bounds, like you're on a basketball court, what happens whenever you cross the out-of-bounds line? They blow the whistle, the game stops, you can no longer in play, right? That's kind of what a boundary line is in math, okay? It's a solid or a dotted line where shading starts and stops. Everybody with me? Solid or dotted line where the shading starts or stops. Now, a solid line, we've covered this before. A solid line is going to be that indicates all the values that fall in that line are allowed to equal it. You get me? They're allowed to equal it. You are going to use the symbols less than or equal to or greater than or equal to with it. Do we get that? Because it's allowed to equal it. Make sense? A dotted line is the exact opposite. Opposite. Yeah, right. Opposite. It cannot equal it. Okay? Not allowed. You're going to use the less than or the greater than symbols with it. Now, there are 2 questions. Did you all copy this down yet? Okay, copy these down. Okay, here we go. These, what lines? Okay, now, 2 questions you got to ask yourself. Is the line solid or is it dotted? The next question you got to ask yourself, is the shading above the line or is the shading below the line? Now, the blue lines, the solid line and this dotted line are called boundary lines. You get me? If you look on the left example, this shading over here is not touching or crossing that solid line. Be quiet. Now, over here on the right example, this shading is not going to cross that boundary line. I don't care. Pretend it doesn't cross. It's not supposed to. Do we understand? How you like me now? All right. Now, do we understand that? Yes or no? We get it? Now, our game plan is to figure out which of those 4 lovely little signs represent these shaded regions. Okay? Now, the question you got to ask is this line solid or dotted on the left? Solid. Now, if it's solid, you automatically have to use the greater than or equal to or the less than or equal to symbols. Does that make sense? Yes. Yes. I had to think for a moment. I was very confused as to what you were asking. So that leaves me with these 2 options. Now, is the shading above the line or is it below the line? Now, what do I mean by above? Pick any dot you want, and where's the shading? It's above it. Do we see that? It's above it. Above means which symbol? Greater than. So greater than or equal to is that shading right there. Does that make sense? Now, go to the dotted line. It is dotted, so which 2 symbols can you use? You can use less than or you can use greater than. Now, is the shading above it or below it? So here's the dot. It's below it, isn't it? Do we see it? It's below it. So I'm going to use which symbol? The less than. That represents the shading. Do we get it? Do we get it so far? Now, don't be getting overconfident, people, because let me tell you, we're going to be on a big ride today, and you might get eaten up by sharks if you get a little too overconfident. Yeah, well, we're parasailing, and you better hope the boat keeps traveling. Here we go. How many of you remember that? What is that? What is it? Zero undefined. Remember, you look over the cliff and it's undefined. You don't know what's down there, right? Okay, that's your slope, remember? That's your slope. Now, here's what you need to know about the slope. I told you this a long time ago. If you have a positive and a negative slope, x and y are both in the equation. Very important to know. X and y are both in the equation. If you have just 0, that means x is equal to a number. Or no, it doesn't. That means y is equal to a number. You get me? If it's undefined, that means x is equal to a number. Why is this important? Well, because you're going to have to remember how to find equations of lines. Oh, wonderful. You ready? Are you ready now? Too bad. 27 out of your book. Number 27 out of your book, it basically gives you this equation of y equals negative x minus 2 with a graph of a dotted line and shading. Your game plan is to replace that equation, the equal sign, with one of the 4 inequality symbols, less than or equal to, greater than or equal to, less than, or greater than. You get me? Now, the way you're going to do that is by asking yourself those 2 key questions. Is the line solid or dotted? It is dotted, which means I am looking at these 2 right there. Is it above or below? The shading is below, which means I am going to be using strictly less than. So my answer is going to be y is less than negative x minus 2. Do we get it? Are we feeling it still? We're understanding. Okay. Ooh, no ooh, same concept. It doesn't change. The question I ask you, is the line solid or dotted? Is the figure solid or dotted? It is solid. Since it is solid, that gives me less than or equal to or greater than or equal to. Is the shading above the figure, meaning inside it? And if you're not certain, what do? We choose a point, and where is it? It's above it. Do we see that? And since it's above it, we have strictly greater than or equal to. Do we understand that, yes or no? So I take that equation to be 2y is greater than or equal to the absolute value of 2x plus 6. Final answer. We get it? Yes? We ready for our next jump? The shark's about to come out of the water and see if it can snag you. What's the difference between this problem and the last one? What? There's no equation, people. Which means you got to come up with the equation first, and then you got to replace that equal sign with the inequality symbol. So, tell me, what is the parent function to this? Y equals x is the parent function, which should bring you way back in the first 9 weeks of slope-intercept. What is slope-intercept form? Y equals mx plus b. By golly, you do listen to me, people. You really do. Y equals mx plus b. What's m? Slope. And graphically, what does slope represent? Graphically, rise over run. By golly. And what is b? What? It's your y-intercept, which is the point 0y, correct? Or in this case, 0b. Do we understand that? Yes? This is all review. Do you remember this? Riddle. Now, you got to be very careful on this because this it goes by 2s. The units go by 2s. Does everybody see that? So the very first thing we're going to do is we're going to find out what our slope is. So our slope is going to be, here is the b value. Agree? What is my b value? 0, 4. Now, here's another point on the graph. Do we see it? 0, 2. Do we all understand that? That's the point 0, 2. And this is the point 0, 4. Now what we're going to do is rise of a run. So I'm going to go up 4 units, and then I'm going to go to the left how many units? I'm going to go up to the left 2 units. So what's your slope? -2. Why am I running to the left? Oh, thanks. Thank you. 2, 0. If I'm going to the left, why am I going to the left, and why is it negative? Because I'm going downhill, right? I'm going downhill. The slope is negative. Whenever I say rise of a run, if I say rise, it always goes up. If I say run, you can run left or right. Do we all agree with that? Okay, so I have my slope being -2. So now, what's my final equation? Y equals -2x plus 4. Excellent. Now we found the equation, correct? Now I have to make it into an inequality. So what are the 2 questions you ask? Is it solid or dotted? It's solid. So what are my 2 options? Less than or equal to, greater than or equal to. Is it above or below? It's above it, so it's going to be strictly greater than. So this is going to be y is greater than or equal to -2x plus 4. Final answer. We're going to get there. We good? Do we understand 41? Yeah, for right now. Okay, what happens if I give you this point and this point, and it's solid, and the shading's that direction? Well, what is on the right side? All the numbers to the right are what? Bigger, meaning larger, meaning greater than. Yes? Stay awake, sit up. So when it's shaded to the right, it's greater than, or equal to. When it's shaded to the left, it's less than or equal to. Do you see that? Now, with that said, it's solid or dotted? It's solid, which means, which one am I using? Greater than or less than, and is it shaded to the right or to the left? So it has to be strictly greater than. Now what's my equation though? Vertical lines are what? Undefined, so what are they? X equals a number, so in this case it's going to be X equals -3, so it's actually going to be X is greater than or equal to -3. And that's it. Does that make sense? Are we good? All right, let's do it again. All right, now obviously Ricky's mind immediately goes to dotted, solid, above or below. So if he wants to do that, it's dotted, which means it's this or this, and it's above, which means it has to be strictly this. So we already have our inequality symbol. Agree, folks? Now we got to do the hard part, which is finding the equation. So whenever you're finding an absolute value equation, what 2 points do you have to have? 1 point has got to be something very specific. What is it? What is that thing called? It's called the vertex. Very good. I got to have that point. So what is that point? -1, -1. That's my vertex. It didn't go by 2's on this one. 1, 2, 1, 2. You see it? Okay. Now what do? Choose another point. I'm going to choose this one, and then you got to do your slope, which is going to be your A value. Do we understand that? So if we do our slope, that's going to go up 1, 2 units, and then 1, 2 units. So your slope is 1. Now, is my V opening up like a V, or is it opening down? It's opening up. You really can't do left and right here, because if you go to the left, you can still get a slope of 2, right? Which then you'd think it'd be negative 2. If you go to the right, you can still get a slope of 2, which make it positive. So you got to ask yourself, is it being reflected or not? And it's not being reflected, so A is 1. Agree? Okay, so now what's your standard form of a absolute value equation? A times the absolute value of x minus h plus k. That's your standard form of an absolute value equation, remember? A is your stretch or your compressed. Do we all remember that A is your stretch or reflect or compress? So y is equal to 1, x minus negative 1, minus 1. There's a lot of 1s there, aren't there? Do I need this 1 right here for my stretch? No, I do not. And minus a negative is a positive. Now, if you look at this, doesn't that make sense that it's going to the left 1 unit and down 1 unit? Can you see that? And can you see that it's not going to be stretched any? And if you would plug and chug, you could be able to see those values better. Okay, now, what do I do with that equal sign? So all I'm going to do is I'm going to replace that and make that a greater than statement. Do we all understand that, yes or no? Bree, are you good? Are you good? Okay. Any questions on that? The K is part of the standard formula. Okay, now, tonight's homework. We're not done yet. Keep your notes out. We're not done. Not yet. Do not hand in your homework yet because I want to go over it tomorrow. Okay, are we checking out our homework? All right, in problems 10, 11, and 12, all you have to do is replace the equal sign with an inequality. That's all you got to do, is replace the inequality, replace the equal sign with an inequality. Ask the questions. Is it solid dot? Is it above or below? You get me? It's that easy. They give you the equations. We good? Okay. Problems. (13 through 18). You have to find the equations like we did. Come on. I need my floating tools. I don't have one of those. Find equation and then do what? And then replace the equal sign with less than or equal to, greater than or equal to, less than or greater than. Do we all understand that, yes or no? We good? Okay, now, 9 through 10. Or 1 through 9. 1 through 9, it says to graph the inequalities. You all are going to need some graph paper. We're going to do problem number 5 together. Okay, so write down problem number 5. Man, one short. Okay, problem number 5. In order to graph this thing, what do you guys have to do? In order to graph it, it has to be in that form. So what I want you guys to do is solve that thing for y right now. Solve it for y. Here we go. Now, we need this in y equals mx plus b form, correct? So what I'm going to do here is I'm going to add 2x to both sides. Negative y is greater than 2x plus 1. Am I done? Why am I not done? I got to divide each term by a negative 1. So y is going to be what? You got to flip the sign. Good job, Miranda. Flip the sign, and that gives you negative 2x minus 1. Do we all see that? Yes? We good? So now, I've solved this thing for y. I flip my sign. That's what I got to graph. Now I got to figure out what my slope is. You're going to eat all of them, aren't you? What's my slope? What is my slope? Negative 2 over 1, which means you rise up 2, and then what? You go to the left 1. Do we see that? Now what's my b value? My b value is the point 0, negative 1. We get it? Do you remember this way back in the day of graphing? You may not have liked it, but we did it. Guys, what is the definition of rise of a run? You always rise up, and then if it's negative, you run to the left, and if it's positive, you run to the right. It's not wrong if you go down and then to the right. It's just that's not the typical direction. What's your slope? It's a negative slope, which means it's, according to our mountain, it's going downhill, right? Right? So that's why you go up 2 and to the left 1, up 2 and to the left 1. You can go down 2 and to the right, down and to the right. Do you see that would have a negative slope still? You can, but I'm always doing the graphical definition of rise means rise. You go up. You don't go down when someone says rise. Okay? Okay, I copy. And paste. So now, I'm going to take this lovely little thing, maybe. My board is off. Yes, it does. So, I graph the point 0, negative 1, puts me right here. And then what do? I'm going to go up 2 units and to the left 1. Up 2 units and to the left 1. My board is so off. Up 2 units to the left 1. Do you see that that's going to be your line? Now, Bree, what did you just say? Why are we dotting it? Because the sign was less than that we used, right? So I have to connect that with a dotted line. There's my dotted line of negative 2x minus 1. Am I shading above or below? It said less than. Do we see it? It said less than. So I'm going to shade that thing below. Do we see it? It has to be dotted. Why does it have to be dotted? Because it's strictly less than, not equal to. Very good. Do we understand that? Now, tomorrow, what do I expect you to have done before you walk in my room? I expect 10 through 18 to be 100% completed. 1 through 9, you might struggle with trying to remember how to graph. I expect it all started. Why wouldn't it be completely finished? well, be found by the time you come here. We'll see.